Hey students, this is Mrs. Morgan with 9-5, the quadratic formula. At the end of this lesson, you will be able to solve quadratic equations using the quadratic formula. What is the quadratic formula? It is right here. When do we use it? When it's not easy to solve by graphing or factoring. Oh, I should mention that these A, B, and C up in this formula, that is from our general form for quadratic equations, that ax squared plus bx plus c. That's where your A, B, and C come from. Also, for your information, is there an easy way to see how many solutions there are? Yes, there is. There's a thing called the discriminant, and it is this highlighted part, b squared minus 4ac. If the value of that is positive, you have two solutions. If it's 0, you have one solution. And if it's negative, you have no solutions. We are going to solve using the quadratic formula and round to the nearest tenth if necessary. Looking here at part A, of course, it is not in the form that we need right away. We need to move this negative 20 to the other side. So we will start with x squared minus 12x plus 20 equals 0. And looking at this, we know that our A is 1, our B is negative 12, and our C is 20. And then it's just a matter of plugging in and cranking away at this. So let's get started. Negative 12 plus or minus b squared, which I'm going to go ahead and square our b and get 144, minus 4 times 1 times 20. And you'll want to make sure that you extend that square root all the way over. All over 4a, oh no. All over 2a, excuse me. So we'll simplify this down. This whole thing comes out to 80. So 64 under here. All over 2. So we will have 12 plus 8 over 2 and 12 minus 8 over 2. And simplifying, our final answers would then be 10 and 2. Moving on to our next example, and this is just another solve using the quadratic formula, and we are already ready to go. So our A is 3, our B is negative 5, and our C is negative 12. If you are feeling brave, you could pause the recording and try it on your own right now. Or we could just move forward. So we will have negative 5, And under here we'll have b squared 25 minus 4ac. And I never make my square root long enough. There we go. All over 2a, which in this case is 3. And so we'll clean this up. So we have 5 plus or minus, ooh, yikes, didn't close that. This is negative 144, but since we have minus negative 144, we'll end up with a positive 169 under here, all over 6. So we will have 5 plus 13 over 6, and 5 minus 13 over 6. And if we were to clean that up further, we'd have 18 over 6, which gives us 3. And negative 8 over 6, which if any of you has the audio on right now, it is very important that you simplify this fraction right here. Those of you who are listening without the sound on, well, you just missed a very interesting moment. We are going to simplify negative 8 over 6 to negative 4/3, please. And thank you. If you want to do this to a decimal as the nearest tenth, it would be negative 1.3 repeating, which is negative 1.3 when we round. So either one of these would work, and this one. So we're going to move on. We're going to state the value of the discriminant for each equation, then determine the number of real solutions. Again, just remember that if our discriminant's positive, there are 2 solutions. If it's 0, there's 1 solution. If there's negative, there are no solutions. So our A is 3. Our B is 10, and oh no, we should have gone 3x squared plus 10x minus 12 equals 0. So our C value should be negative 12. Okay. So we have 10 squared minus 4 times 3 times negative 12, which is 100 minus this whole piece here is negative 144, and minus that negative is the same thing as plus positive. So we have a discriminant value of 244. So we found the value of the discriminant, and if it's positive, that means there are 2 solutions. And that is quadratic formula. Thank you very much.